Hi guys, today is March 27th, so 3/27, and we're going to learn about graphing logarithm functions today. Now we've already done this when I did parent functions way back in August and September, but we're going to be a little more detailed with this, and we're going to graph logarithm functions using transformations, okay? All right, so this first graph, if you look at it, okay, I noticed that at x equals 1, it's 2, right? So that's telling me, and we know by the shape of this that that's an exponential, okay? So this is the graph of y equals 2 raised to the x power, okay? And then this one over here, if you look at x equals 1, it's a little different, right? It's not 2 and it's not 3, it's about 2.7, okay? So that's telling me that this is probably, and it is, okay, the graph of y equals e to the x. Because remember, e is approximately 2.7 dot dot dot, right? Okay, so I know that this is the graph of y equals e to the x power. Okay, so what's the inverses of these? Well, they're logarithms, right? That's what we've been studying. Okay, so how do we undo base 2? We take the log base 2, right? So this we're going to graph. This is going to be the graph that we're going to graph by hand. Y equals log base 2 of x. And then over here, what we're going to do is log base e. But log base e has a special name. It's y equals natural log of x. So y is equal to ln of x. Okay, and we're going to graph these two functions and take a look. This was a parent function that I had you guys graph way back. Okay, all right, so a couple things that we want to look at on the exponential graph is this has a horizontal asymptote, right, at y equals 0, okay? So that means the logarithm, because they're inverses, okay, that horizontal asymptote is going to become a vertical asymptote, okay? So we're going to graph a vertical asymptote at x equals 0, excuse me, at x equals 0, okay? So that's going to be an important feature of these logarithm graphs. So it's x equals 0. Okay, it's going to have a vertical asymptote right on the y-axis. Okay, and the other feature that's going to be important is that the exponential is crossing at 0, 1 right here. That means the logarithm graph is going to have to cross at 1, 0. So that's going to be an important point. So when you graph these, I'm going to be looking for the vertical asymptote, and I'm going to be looking for this locator point, okay? So this locator point is the point 1, 0, okay? So over here on the negative x-axis, that's where it's flattening out, right? Well, over here on the negative y-axis is where it's going to be vertical, okay? Because it's horizontal here, it's going to be vertical here. So our graph is going to come up along the y-axis, the negative y-axis, go through the point 1, 0, and then turn. And that's really all I'm looking for, okay? I'm going to be looking for this being moved left and right, and this point being moved left and right, and also up and down, okay? All right? All right, now this one over here, okay? Well, this one also has a horizontal asymptote, right? Okay, the exponential y equals e to the x has a horizontal asymptote. So that means the graph of the inverse function, which is this natural log of x, will have a vertical asymptote, and it will have it at x equals 0 again. So we'll graph that with a dashed line. And that's x equals 0, okay? And then the point 1, 0 is right here, y10, because 0, 1 is on the graph of the exponential. So 1, 0 has to be on the inverse function. So it's going to be this almost the same graph, okay? So right here on the negative x-axis, it's horizontal. That would mean that on the negative y-axis, it's vertical, okay? So it's going to come up along here and then turn and go through the point 1, 0, and then turn. Now, these are different graphs over in here, but this is about the shape of it, okay, and the features of it, especially like the vertical asymptote, okay, because there's no value for the function over here. Do you notice that? So there's no value for the function at x equals 0, and there's no value for negative x's, right? So what does this mean? This means this x right here, we can only put in positive values. This x right here, we can only put in positive values. This is called the argument for log base 2. This is the argument. X is called the argument for the natural log here. Okay, so whatever we're taking log of, that's called an argument. All right. Okay, so what do we know about this? We know that this x has to be greater than 0. And we're going to use that to figure out our domain. Okay, x has to be greater than 0. So for these two graphs, okay, for this one right here, our domain is 0 to infinity. Now that's describing just positive x's. And our range is negative infinity to positive infinity, because it takes on all the y values. This keeps going up. This is the slowest growing function that there is. It really grows really slow. Okay, and then over here for the natural log, excuse me, the domain is 0 to infinity, and the range is also negative infinity to infinity. So the range is always going to be negative infinity to positive infinity. The domain will change based on if it's been translated left or right. Okay. All right, so that's all we know about graphing the logarithm function. Okay, it's about just this shape. It will have a vertical asymptote and the 0.10. Okay. All right. Okay, so this is just going to be, this first example is just a kind of a quick little review along with some new stuff. Okay. For this function, f of x equals 7 times the square root of x minus 5 minus 4, and minus 4 is on the outside. The argument for this function is x minus 5, because that's the part that's inside the square root, okay? All right, so what's the domain? Well, for even root functions, remember, whatever the argument is, that has to be greater than or equal to 0. So for the domain, we'd have to solve x minus 5 is greater than or equal to 0. Why? To get real number outputs, what's underneath here can't be negative. It has to be positive. It could be 0 because the square root of 0 is 0, okay? So then all we need to do is solve this, right, and add 5 to both sides, and we'd have x is greater than or equal to 5. Now, there's two ways you could write the domain, okay? So the domain could be written with an inequality like this. So x is greater than or equal to 5. Or another way to write it is bracket 5 to infinity. Okay, because if we put 5 in here, that'd be 5 minus 5. That would be 0. The square root of 0, that would be 0. Okay, so you can square root 0. All right. Now, the next example, okay, is f of x equals 3 over x plus 5, okay? Well, this is a little bit different, right? What's true about this type of function is that this denominator can't be 0. So x plus 5 cannot be 0, which means x cannot be negative 5. We've looked at this a lot. I bet you could have told me that already, okay? And so x can't be negative 5. That means it can be anything else. So that means the domain is negative infinity to negative 5, parenthesis, union, negative 5 to infinity. Okay, and now for the new one, okay, the logarithm. And this is natural log, right? Okay, but it's still a logarithm, all right? So from above, okay, we know that that this argument for the natural log, the argument here is x minus 4. X minus 4 can't be 0. It can't be negative. It has to be positive. So how do we show that it has to be positive? We see x minus 4 has to be greater than 0, which means x would have to be greater than 4. Now, one thing to take into consideration when we do inequalities, okay, if you have to multiply both sides or divide both sides by a negative, when you do an inequality, you solve an inequality, that means the direction of the inequality must change, okay? All right, so just take that into mind. Like if this was 4 minus x, and this was a negative x. Okay, we would have had to divide by -1, and then the direction of this inequality would have had to have changed. Okay, all right, so then there's two ways we could write this domain. Okay, so we could write domain, and we could write it as an inequality. So we would say the domain here would be x is greater than 4, or if x is greater than 4, in interval notation, we would say parenthesis 4 comma infinity, 4 to infinity. Okay, that's everything greater than 4. Okay, just two ways of writing it, inequality or interval. It's whichever way you prefer. I don't mind. You do it either way. I'll accept it. Okay, all right, you're going to see me probably do more inequality for these because you're solving an inequality. Okay, just know that. All right, you guys take care, and we'll do the next example. Okay, for this this next example, okay, we want to graph f of x equals log base 2 of x plus 1 minus 2. Okay, from before, we should know that we're going to take the parent function. We're going to take y equals log base 2 of x, and this x plus 1 causes a translation left 1, and the minus 2 on the outside of the parent function causes it to translate down 2. So we're going to take this function and we're going to translate it left 1 and down 2. Okay, so what do we know? We know that the original parent function, okay, all logarithms have a vertical asymptote right on the y-axis. Always has a vertical asymptote on the y-axis, but that vertical asymptote has been moved to the left 1. Okay, so now that vertical asymptote, is going to be, if we move it to the left 1, it's going to be at x equals -1. Okay, so it's going to look like this. And that'd be x equals -1. Something to take into consideration too, okay? Whatever causes this argument to be 0, that's where the vertical asymptote will always be, okay? So if x is -1, -1 plus 1 would be 0. You're going to have a vertical asymptote at x equals -1, okay? So whatever causes this argument, the x plus 1, to be 0, okay, that's where you're going to have a vertical asymptote. This minus 2 is on the outside. That's not the argument. It's just the x plus 1 part, okay? All right, now, the next thing is we had a point, right, for the original function. We had a point at 1, 0. That point has now moved to the left 1 and down 2. So now that point, I'm going to take this point and move it to the left 1 and down 2, and that's where my new point is. Okay, so that means, okay, it's going to come up because there's no reflections. We haven't done any reflections or anything like that. Okay, it's just translations. Okay, we're going to come up along this vertical asymptote. We're going to turn it. All right, and I'm not going to worry. Okay, it's important that you go through that point and we show the behavior of the vertical asymptote. I'm not going to care really where it's crossing the x-axis. Okay, that's really not that important for what we need for future math classes. Okay, we want to know where this vertical asymptote. That's actually the most important thing. It's even more important than this point. Okay, this is just showing that you understand that the function moved to the left 1 and down 2. What happened is the vertical asymptote moved down 2, but you can't really see a vertical line moving down. Okay, all right, so what's the domain for this? Okay, so from the graph we could say the domain, just reading the graph, would have to be -1, not including, because there's a vertical asymptote there. Okay, the domain would be -1 to infinity, and the range is -infinity to infinity, because it goes down forever and it keeps going up forever. Okay, and then remember the range is your y values. All right, so the next problem, okay, the next problem is, let's graph f of x is equal to the natural log of x minus 3 plus 1. Okay, so we're going to take y equals ln of x, that's the parent function, okay, and this x minus 3, causes it to be translated to the right 3, and the plus 1 causes it to translate up 1. So we're going to take y equals natural log of x and translate right 3 and up 1. Okay, so where would, now again, where's the vertical asymptote on the parent function? It's always the y-axis. Well, now that's been moved to the right 3. So we're going to have a vertical asymptote right here at x equals 3. So we'll use a ruler and draw that vertical asymptote. And that's x equals 3. Okay, now normally the parent function has a point at 1, 0. That's been moved to the right 3 and up 1. So 1, 2, 3 and up 1. That point is now right here. Okay, and once again, we're going to come up along this vertical asymptote. It's so close that we can't tell the difference. And then we're going to turn it and go through this point at 4, 1. And then it goes like this. Okay, and what's the domain for this? The domain for this one would be from 3 on, 3 to infinity, not including 3 because it has a vertical asymptote at 3. So the domain would be 3 to infinity. And the range would be negative infinity to positive infinity. Okay, and that's how you graph logarithm functions. Okay, and that's what the homework is going to be today, all right? All right, so after today's lesson, what I'd like you to do is worksheet ELF 7, and let's just put today's date. And again, this is just helping me to keep track and you keep track. I'm going to assign this on Google Classroom. It'll be due in a couple days from, I think I'm going to post it today. I think I'll have time to edit this video and everything else, okay? All right, I sure miss you guys. I miss seeing you guys, your happy faces. So I will see you guys soon, okay? You guys take care and good luck.